Okay, so this is the fifth problem in the Thevenin series. So let's go ahead. Uh, this is Thevenin underscore 5. Let's start drawing the circuit. We have a voltage source of 10 volt and resistance here, a diamond right here, okay, and resistance here, another piece of resistance here, another piece of resistance here. The open end terminals are A and B. Let's go ahead and write the numbers here. This is 5 ohm. Okay, this is a voltage dependent current source. 2/3 piece of X. Now the base of X shows up here, across the 3 ohm resistor. Okay, so this is base of X. What else? This fellow here is 20 ohm, and under here is 1 ohm. I think we got them right. Okay, so the target here is to uh, determine the Thevenin equivalent circuit for this given circuit. So we're asking to find P Thevenin and then R Thevenin resistance, that is, and also the max power this circuit can deliver to an appropriate load, which is the same as the Thevenin resistance, as we know. So let's get started finding these quantities. So to do this job, let's say this is mesh number 1, so having current I sub 1. This is mesh number 2 with mesh current I sub 2. So what that means is, at this point, as we see, I sub 2 minus I sub 1 is the balance current across the diamond, or through the diamond, shall I say, is 2/3 of piece of X. Okay. Right now, there is no current flowing across the 3 ohm, and piece of X is the voltage across this 3 ohm resistor. So using Ohm's law, we conclude that as of now, uh, there is no voltage across the 3 ohm resistor because there is no current flowing across through it. So as of this point, let's just put a barrier here. As of this point, uh, as of this point, piece of X is 0. Okay, let's realize that. So I2 minus I1 is 0, is what this thing is saying at this point. Uh, so piece of X equals 0 implies I1 is equal to I2 at this point. Now let's write this heading: determination of P Thevenin. Okay, so if we go finding the supermesh, mesh of number 1 and number 2, and use KVL, we're gonna get minus 10 plus 5I1 and plus 20 I sub 2 equals 0. But we just said that I1 is I2, so we're talking about minus 10 plus 5I2 plus 20I2 equals 0, or 25I2 equals 10. So I sub 2 equals 10 over 25n, meaning PAB, which is equal to, at this point, 20I2 there is no voltage across the 3 ohm resistor, none across the 1 ohm resistor. So that's why this is simply 20I2 will give us the open circuit voltage, and that is what we call the Thevenin voltage. Since we know I sub 2, we are going to get Thevenin voltage here, meaning PAB is 20 times I sub 2, which is 10 over 25 amp, so 200 over 25. Therefore, PAB is 8 volt, which is to say P Thevenin is 8 volt. So this is determined. Next, we will determine the R Thevenin. And to do that, what we will do is we will short circuit the open end. That's a pretty standard technique. When we short circuit the open end, we will determine the short circuit current. Let's start with the circuit. So we have the voltage source of 10 volt on the left, 5 ohm resistor on the top, and the diamond, of course, here. We have the resistor here, we have the resistor here, we have the resistor here. This used to be our open end NB, but now we're gonna short circuit this A and B, and the current that flows here is the short circuit current, which is also called the Norton current. And R Thevenin will be the ratio of the Thevenin voltage to this short circuit current, or Norton current for that matter. So once we determine ISC, we will find RTH. That's the idea. So let's go ahead and put the numbers in here. The resistance here on the left top is 5 ohm, as we know. The diamond has 2/3 P sub x, where V sub x is what now? That's the voltage with the plus on the right side, minus here, right here. Now this is 3 ohm. Down below we have 1 ohm, and this is 20 ohm on the left. Okay. So once again, we will use the meshes. This is I sub 1, as we said previously. This is I sub 2. And now this time we also have I sub 3, because we have the third mesh here as well. So what do we see is I sub 3 is actually the same ISC. So our goal is to find I sub 3. When we do that, we will eventually get the R Thevenin. Now, let's get P sub x, because we have to have that expression to know just what the diamond is doing here. So P sub x would be the voltage across 3 ohm, but with the plus and minus as shown, we realize it's a minus 3 times I sub 3, because notice the plus should be on the left and minus should be on the right, as I sub 3 is going from left to the right, but the way it's shown, the opposite is the polarity. Once again, well, tell you what, I'm gonna wipe this thing. It's kind of messy here. So I'm gonna take this thing out here. All right. So I will write here P sub x equals minus 3i3. So that's better. Okay, let's continue this problem now. So we have the value of the diamond as I2 minus I sub 1 equals 2/3 p sub x, which is then 2/3 of minus 3i3. The 3's cancel out, so this is simply minus 2i3, meaning we have I2 minus I1 plus 2i3 equals 0. Wait just a second here. Okay, 2i3. Now let's put this in a box and call it equals 1. How about that? That will be just fine. Next, we will go through this super mesh consisting of mesh number 1 and 2, and use KVL. So we are going to find minus 10, okay, plus 5i1, what else, plus 20, okay, I2 minus I3. Notice that I2 is competing with I3 here, equals 0. So we can simplify by dividing everything by 5, which will give us minus 2 plus I sub 1. The 20 becomes 20 over 5, that is 4. So we can expand the parenthesis, which will give us 4i2, and then what? Minus 4i3 okay, equals 0. So we can express this as I sub 1 plus 4i2 and minus 4i3 equals 2. So let's put this in a box again and call it number 2 equals number 2. If we look at equals 1 and 2, it looks like we can eliminate I sub 1 by simply adding these two equations. Let's do just that. So I sub 1's will cancel out. I sub 2 will add up. Okay? So the end result is by adding, look at this, adding 1 and 2, we get what now? I sub 1 cancel out. 4i2 and i2 is 5i2. What else? Let's say. Then 2i3 is plus, minus 4i3 gives us a balance of minus 2i3, right? Equals 2. How about that? Now, let's store this as number 3. We will get to work on this a little bit later. So, now, let's look at mesh number 3 and use KVL. Mesh number 3, KVL. It's going to give us I3 times 1, which is I3, plus 20. I3 is competing against I sub 2. I3 prevails. I3 minus I sub 2. On the top, we have plus 3i3 equals 0. So we can expand the parenthesis, which gives us then I sub 3 plus 20i3 minus 20i2 plus 3i3 equals 0, which we can simplify. Let's look at it. I3, 20 I3, and 3 I3 will give us a total of 24 I3. And if we move the 20 I2 to the right side, the minus will be plus. In other words, if we divide both sides by 4, we're talking about 6I3 being equal to 5I2. Wow. We can take this to number 3 where we see 5I2. Now we know 5I2 is simply 6I3, right? So where we had 5I2 in number 3, equals in 3 gives us now clearly 5I2 being the same as 6I3 minus 2I3 equals 2. That's wonderful, because now it gives us a balance of 4I3 being equal to 2, or I3 is 0.5 M. But then I3 is ISC, short circuit current, which is 0.5 M. That tells us R Thevenin is P Thevenin over ISC is simply 8 volt over 0.5 amp, giving us 8 over 0.5 ohm. Therefore, R Thevenin is 16 ohm. So the max power we can deliver with this circuit is given by what now? VTH squared over 4RTH. Wait a minute here. It doesn't look like R, this one. Let me clean this thing up a little bit. Okay. So RTH. So that will be PTH squared is 8 squared. 8 times 8. And for RTH is 16. That will be simply 64 over 64 watt, which is simply 1 watt. There we go. So this is the max power the given circuit can deliver. That's about it. I hope you enjoyed this problem. I had a terrific time doing it. You take care.